All right, so the EEE203 midterm, picking up on 6B, we want to determine the stability and causality of the system right here. Here's our definitions. We talked about in the previous video. Go back and watch it if you need to. Um, let's take a look at this unit step real quick. So we have unit step of 1 minus t, and that's going to be equal to u of negative 1. I guess we don't need that 1 there. We just say negative t minus 1. And you should be comfortable with, we should be comfortable with this by now. This is going to be 1 when t is less than 1 and 0 when t is greater than 1. Now let's test that. Let's go u of negative, let's say t0. And then what we get is unit step of, we have a negative and a negative, so that becomes a positive, and that's equal to 1. And then let's go on the other side. Let's say t is 2. We have negative 2 minus 1, and that's equal to unit step of negative 1, which is equal to 0. And so what we have is a left-sided system. And when I say left-sided, I mean if we had h here and t here, well, you know, this is 1. We're 0 all the way over here, and our system is doing stuff over here, which means it's left-sided because we're on the left side of the plane going this way. That's we'll talk more about that in upcoming modules. So let's now that we know what's going on here, let's just plug in a value to test for the causality. Let's plug in negative 1. Well, we get e to the negative 3 times negative 1 times the unit step of 1 minus negative 1, and that's equal to e to the 3. Unit step evaluated 2, which is equal to e to the 3. And we know that that does not equal 0, so it's not causal. Now for stability. Well, our system can't ever be negative because it's decaying. It's an exponential. It's actually going to be growing on the left side. It's not decaying. It'll be, if this unit step wasn't here, it'd be decaying on the right side, but because we're the left side of function, it's going to be exponential growth, which should already kind of hint to what the answer is. But let's go through the steps. So we need the integral from negative infinity to infinity, h of tau d tau, and we can simplify our bounds because we know when it turns off. So it's going to be that's going to be going from negative infinity to 1. And like I said, it can't ever be negative. So it's going to change out e to negative 3 tau d tau. And then we perform the integration of this. And we're going to get negative 1 over 3. Negative 1 over 3 e to negative 3 tau. And that's going from negative infinity to 1. And when we keep working this through, we get negative 1/3 times e to the negative 3 minus the limit as b goes to infinity, or as b goes, we can do infinity, and we'll get negative 3 times negative b, which that's going to be equal to negative 1 over 3 e to negative 3 minus the limit as b goes to infinity of e to the 3b. I've got this e here. And let's distribute this minus sign. We get 1 over 3. The limit as b goes to infinity of e to the 3b minus e to negative 3. And this limit, that's equal to 1 over 3 infinity minus e to negative 3, which this isn't technically proper mathematical notation, but that is not less than infinity. So it's not stable. So h of t equals e to negative 3t u1 minus t is not causal, and it's not stable. Man, that's just poor handwriting right there. Stable. All right. Thank you. I'll be back with some more videos.